Hello and welcome back to my Blind 75 Python solution series. Today we're going to be taking a closer look at LeetCode question 33, also known as Search in Rotated Sorted Array. This is a medium level question, and I will be solving this problem using binary search, and our answer has an O log n time and an O1 space. I'm also going to be using a new way to solve for our mid variable that I learned is better than the way I showed you in the previous video. The way I showed you to solve for mid in the last video works, but can cause overflow if the sum of start is greater than the maximum positive integer value. That might sound confusing, but just know that this way that I'm going to show you later on in the video is a better way to do this, and it does exactly the same thing as the other way to solve mid. Before we read through the problem, please take the time now to subscribe to my channel and like this video. Really helps me out and it's greatly appreciated. Alright, sweet. Now that you've done that, let's take a look at the problem. So, for this problem, there is an integer array nums which is sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, such that the resulting array is nums k plus 1, nums n minus 1, and so on. For example, this array might be rotated at pivot index 3, and then it becomes like so. So given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it's not in nums. And then you want to make sure that we're writing an algorithm with O log n runtime complexity. So LeetCode is telling us that they are looking for binary search, and that is what we will be giving them. So if we take a look right now at the example, the first example, as you can see, the pivot right here is on the left side. It starts at the 4, and our target is actually over here on our right side. And this is kind of how we're going to be looking at our problem. We're going to be breaking the problem down into a left and a right side. So one side's be left and right, and the first thing we're going to do is we're going to be finding that pivot point. So we're going to be looking for the pivot, and then we're going to look for left versus right for that target point. So without further ado, let's take a closer look at the problem. So right here, I've created our nums array, just like we saw in the example problem. And up above it, I have the index values. And the only reason I included the index values is so that we can kind of keep an idea of that as we go along. We also have our target of 0, which happens to be in the 4 spot. So at the end of this, we should be returning a 4 if we do this correctly. And as we go along this problem, we're going to be keeping track of 3 main variables. That's going to be our start variable right here, our end, and our mid variables. And our start variable is going to start at the beginning of the array. Crazy, right? So we're going to start at 0. And this is just going to be start. And then our end variable is going to be at the end of the array. And so it's going to be in the 6th spot, so it is 6. And then this is going to be end. And then let's now look through our steps. So we have our first 2 variables, which we're going to create before we even start our loop. And the loop, once again, is also going to be a while loop, but we're going to go through that later as we go through the problem. So for step 1, what we're going to do first is we're going to find the midpoint. So if we take this problem, and I'll show you in a little bit later how we're going to look at this, because I told you we're going to change it a bit up from what we did in the last problem. We're going to find the mid, and in this case, the mid is going to be 7, which is also going to be 3. And so on this side, I'm going to save it by index, and I'm going to kind of keep index over here. So just know that this side is going to be our index values, and on this side, we're going to be keeping our actual number values, because we do want to keep track of those, but that's not what we're going to be returning at the end, because we have to compare it to our target. So our target is an actual value that we're going to be comparing against. So here, values, here, index. So now that we found our midpoint, we can actually add these over to the side here. So these are going to be, and as I said, these are values. So this is going to be 4, 2, and 7. And we're going to check if the mid value is equal to our target. And if it does, we're going to return mid. But as we can see, our target is 0. So 7 is not our target, and so that means that we are not done solving yet. And at the end, we will be returning mid. So we're trying to get the mid value to be at our target value. So let's continue on. So if start value is less than or equal to mid value, then check if start value is less than or equal to target, less than or equal mid value. So first things first, let's check if our start value is less than or equal to our mid value. Is 4 less than 7? Yeah, 4 is less than 7, so that does work. So if that works, then let's take a look at our next step. If start value is less than or equal to target value, less than or equal to mid value, then what we're going to do is if it is, then end is going to equal mid minus 1, else start is going to equal mid plus 1. So is our start value less than or equal to our target value, which is less than or equal to our mid value? No. Our start value is a 4, and so it is bigger than our target value, which is 0. So because of that, start is going to now equal mid plus 1. So we're going to move our start value over. So our mid was 7, and our start is now going to be at this 4 index. So we can change start here, and start is now going to be at the 4, and our end is not going to change. It's still going to be at that 6. But when we calculate mid this time, our mid value is going to be at our 1. So this is now the new mid, which is still not our target value, so we're going to have to keep going. And I'm also going to write down the values here as well. So we got the 0 value for start, we got the 2 for the end, and then we have the 1 for the mid. So we have those values, so let's continue. So if start value less than or equal to mid value, is it? Yeah. Then check if start value less than or equal to target, less than or equal to mid value. So is our start value less than or equal to target, less than or equal to mid? Start is 0, which is less than or equal to target. That's true. Less than or equal to mid value. So if it is, then end equals mid minus 1. So end is going to move over again. We're going to change these. And now start and end are at the same place. So if start and end are at the same place, we can read through the rest of the problem. If start value greater than or equal to mid value, then check if mid value is less than or equal to target, less than or equal to end value. And if it is, then start equals mid plus 1, else end equals mid plus 1. And if we don't find our target, return negative 1. So in this case, we don't have to do this part, and I just went through that because that would be in the case that we had it on a different side, but we do not have that in this situation. So we originally, the reason that we're going to do that if start value is less than or equal to mid value versus is start value greater than or equal to mid value is because we're checking first if it's a left side pivot point. So pivot point is here at the 4 versus a right side pivot point. So if our pivot point was over here on the side somewhere, which it's not. So because our pivot point was on the left side, that means that we're going to be doing this step 3 as opposed to the step 4. And I read through the rest of the problem just so that we can get through the rest of the problem. So lastly, all we're going to do is look for the mid. If we take the mid of the two numbers at the same place, the mid is going to also be here as well. And so we're at our mid value, which is going to be 0, 0, and 0. And these are all going to equal 4. And so we got our mid. So at the end of this, we're going to return 4. And that is our answer. Okay, so let's code up this problem. So we have let's create our function. So we're just going to call it search rotated. And inside of it, we're going to have our two variables, nums and target. And what we're going to do first is we're going to create our start and end pointers, which for our binary search. So 0 equals 0, len nums minus 1. So at the start and the end of the array. And then next, we're going to create our while loop for as long as start is less than or equal to end. So if start is less than or equal to end, we can continue. And then we're going to find our mid value. And so this was the way that I said that we're going to change out how we're going to write this. Before I said we could write it like this, which was start plus end floor division 2. That would work, but that would cause issues for overflow. So instead, we're going to write it this way. So start plus end minus start floor division 2. And this is just the better way to write it. So this line right here, remember this line. So what I said before, that does work, but in case of huge big arrays with lots of numbers, this is the best way to write it. The next line is going to look like this. If nums mid equals to target, then we're going to return mid. And so this is our return statement here. It's all the way up here. And this is what we're going to be returning. We want to get our mid pointer on top of our target value. So if nums mid equals target, then we're going to return mid. And then for the next line, we're going to start searching through the array. So in the situation that nums mid does not equal the target, then we're going to need to search through the array. So if nums start is less than or equal to nums mid, and this line is going to check if the array is rotated on the right or left side of the array. And this if else statement that we're going to create is going to check if the rotation is on the left or the right side of the array. So we're looking for that pivot. And in this situation, start less than or equal to nums mid, that means we're going to be checking for the left side pivot point, which is what we looked at in our example. We had a left side pivot point as opposed to a right side. So of course in coding, you always have to think about both situations, so this handles that situation. Next line after that is going to be if nums start is less than or equal to target, less than or equal to nums mid. And then if that's so, then end equals mid minus 1, and then else start equals mid plus 1. So if our start value is less than or equal to the target and less than or equal to the mid value, we need to move our end to our mid minus 1 because our target value is going to be on the right side. Else, if that's not the case, then we need to move our start to the mid plus 1 because our target is on the left side. So this part checks for our pivot point, and then this part checks if our target is on the left or right side. So now we have to create our else statement. So in the situation that our start was greater than or equal to our nums mid, then if nums mid is less than or equal to the target, less than or equal to nums end, then start equals mid plus 1, else end equals mid minus 1. So in that situation, it's just vice versa. And in this situation, what we're looking for is if our target is going to be on the right side, else our target is on the left. And then lastly, all we're going to do is we're going to return -1, just like the problem said. And I wrote out some print statements, run the problem, and as you can see, we get our values, and this is our solution. So I hope this video helped you out. If it did, please subscribe to my channel and watch the rest of my series. I'm going to be finishing out this Blind 75 hopefully in the next month or two, and I hope that you can be along for the journey. This is a great way to help you prepare for your interviews, so please stay tuned for more. Until next time, I hope you have a great rest of your day, and happy coding.